Hi, I'm Jakob Heitz from Cisco. I have another idea for the route leak protection. Okay, what is a route leak? If you're an AS and you receive a route from one other AS and you send it to the other AS and neither side is paying you, then you're leaking the route. So that's basically a route leak. Why does anyone care other than the AS that's actually doing the leaking? And that is because the AS that's doing the leaking usually is a small customer AS, and he has very small pipes, and if you send the whole internet to him, he's going to drop it all. So that's why you care. What did I write there about that? Okay. So the concept of this one is that suppose customer AS3 there has two transit providers, AS1 and AS2. Now, he sends a route, and in that route he puts a community that says my transits are AS1 and AS2. So that now AS1 will receive a route through the other way from AS2. Now he looks at the community that he already got and says, yes, AS2 is a transit, so okay, that route is not a leak. Now AS3 sends the route to AS4 as he normally would, but AS4 sends it on to AS1. But AS1 already has that community from the other route that says AS4 is not a transit. So now AS1 can see, well, I received it from AS4, but AS4 was not a transit, so that must be a leak. So that's the idea. Right, now to encode this, I've decided to do that in BGP and to encode it on each route individually. And the reason for that is that you may be sending certain routes to certain transits and other routes to different transits. There are some CDNs around that will have lots and lots of transits, but they send a single route to each transit, but not to any of the others. So the relationship, the transit peer customer relationship is different for different routes. So I put the information onto the route themselves. Right? Also in different locations, in different regions of the world, you might have different transits. So you want to do that. You want to send the route in those locations with those transits and in other locations with other transits or not transits. No. I have found that the large community is a convenient place to put that information. So that's what I chose to do. So in the large community, again, we have three 32-bit fields. So I've chosen to use the first field is to be the well-known number to say this large community indicates a route leak protection. And then the other two is the nominating AS and the nominated AS. So the nominating AS is the one who says, these are my transits. Now, if an AS does not have any transits, then he nominates AS number 0 as being my transit. That is to distinguish those ASs that do not send anything and those ASs that have no transits. What do we got there? So that's just detail there, which Let me just read that. Okay, next one. Yes. There are sometimes an AS will split a prefix and send split prefixes to a content provider, perhaps, in order to do the traffic engineering to say, oh, I want parts of my network to come through here and other parts of my network to come through there. And so they split the prefix and send it to the content provider. Now, when the content provider leaks those more specifics out to the internet, then all of a sudden they just draw all the traffic for that and they drop it, right? Which happened in Japan a month and a half ago, I think. So my answer for that one is to put another route leak protection community in that says this is a transit for all of the more specific routes to this route. Right? Okay, so now we have two of them. We have one that says, these are my transits for this route, and the other one that says, these are my transits for all of the more specific routes of this route, the ones with the longer net masks. Okay, so how do you find a leak? Now, so 64500 sends two of these. It says, so along the top here we have nominated is 64500, my transit is 64501, and another one that says my transit is 64502. Now on this same route, he also gets another one from that guy on the right, 501, and 501 has no transits, so he just sends the one that says my transit is 0. So these are the RLPs that 502 has received from wherever it's receiving them from. Now we get a route. Let's get the red one at the bottom. So 64500 sends off to the left to 504, who sends it up to 502. So 502 gets an AS path in that. The AS path is 504, 500. So he's going to look at 64500, says, do I have any RLPs for 64500? Yes, I do. That's the first two there. And is 64504, is that in the list of transits? No, it's not there. We have 501, we have 502, but we don't have 504. So 504 is a leak because it cannot follow from 500. There are some other proposals in the IETF how to fix this. One of them is to put a bit into in-band into the actual route that is leaking. Now, that requires the AS that's leaking to pass that bit through. Right? And as some of you may know, there's no such thing as a transitive attribute in a BGP anymore because some years ago there was a few bugs where routers crashed because they had unknown attributes sent, and then we all went and put this protection in so that you can drop unknown attributes. And so a lot of people drop unknown attributes. So transitive attributes get dropped. Unknown transitive attributes get dropped. So, so for this proposal, the leaking AS does not need to pass anything. It does not need to upgrade any code. Now, a Tier 1 transit or any transit can sell this route leak protection to its customer. The customer puts a community, that was a part I missed. There's a way to do this with a regular community. The regular community is smaller, so you can't put all the information in. In a regular community, you can only say, this one is my transit, but he has to be 16-bit AS. So in that case, the customer writes into a community, these are my transits, and then the ISPs will pass that along amongst each other. Okay, I have the route servers in there, the IXP route server. The route server does not put its ASN into the AS path, so there's no way to check whether the route server leaked anything. Now, a route server does not actually need to have any transit or peer or customer type of relationship with any of its clients because it doesn't put its ASN into the AS path. The actual IXP route server clients themselves have relationships amongst themselves only. Right? What I have there, the ISP can sell a route leak protection to the customers without having to rely on other ASs to cooperate because it's only through them. The leaking AS does not have to cooperate. Okay. Okay, now I have a few more examples here. What's this one? This is a typical valley leak. So AS1 sends a route to its customer. Its customer has dual home. It sends it to its other home, and because the route leak protection is passed through between peer ISPs, the receiving ISP can detect that, here we go, AS1 has no transits. It says to AS2, I have no transits, but we got a route from AS1 through AS3, so that's detected as a leak. Okay, here is one that could be seen as a leak. Here we say AS1, no, AS1, I don't have any transits. He sends that to his peer, but his peer sends the route to the customer. The customer sees an AS path, right, where it appears that AS2 is transiting for AS1. So that could be a leak. However, the route was received from a transit itself, therefore it's not a leak. So that's part of the rule. If you receive it from a transit, these RLPs don't matter. Right. This one's probably pretty similar to the first one. AS1's a tier 1, he's got no transits. Sends to AS2, but AS2 sends to a peer, and again, from the RLP we can see AS2 is not a transit, therefore it's a leak. Okay, this one is, again, so AS2 is originating or passing on a customer route. He says, my transit is AS1. He also sends it to a peer. The peer is supposed to actually only send to a customer, but he sends it up to the transit. So again, we see the AS path with 3 after 2, but the RLP does not list 3 as being a transit, so it's detected. Okay, this was the more specific that I was talking about. So AS2 peers with the content provider AS3. He has a route 10:/12, so that's his aggregated route that defines his total network, and he sends that to the internet. But he splits that prefix to 10:13 and 18:13, so that's split the prefix because he wants part of the traffic from AS3 to come across the top and other parts of the traffic to come across the bottom. So that's how he achieves that. But now AS3 leaks one or both of those more specifics to the internet again. Now with the covering route leak protection, AS1 can detect that there should be no transits for any more specifics of 10:12. Okay, this is another one, but the RLP, the route leak protection community, originates at AS2. It goes to the Tier 1 provider, AS1. Now, AS1, he shares it with AS4, and they trust each other to do that. So AS4 detects the leak because AS3 is not a transit. So this is the case where the route leak protection community is shared with a Tier 2 provider. Transits share the route leak protection. So this is the case I see. I would imagine mostly would happen that the Tier 1 provider receives it from its customer. They send it to all of their peers, and that's as far as it goes in most cases. So we can detect that here. So AS2 is originating. It sends route leak protection up to its transit, but it sends the route across to its peer. Its peer leaks up, and the Tier 1s have shared the route leak protection. So AS4 knows about it. AS4 knows about who its transits are from AS1, and it receives the route from AS3. It receives the leak from AS3. So I think that's the biggest point here, is that the route leak protection community travels across the top, and the leaks travel in a different place along the bottom. Okay, this is the example about the route servers. The route servers cannot have any relationships with its clients. You see here, AS1 is a provider to AS2, but AS3 is a customer of AS2. So for that to occur, there is no possible relationship that AS2 can have with the IXP in order to make those other relationships work. Right now here, I've invented some configuration for iOS XR. So the way that this would work in the software is that the software would match the route leak protection communities against any received routes, and then mark any received routes with a validity bit that you can test in the route policy. If not accepting forwarded RLPs, then you delete these large communities. the route leak protection communities should really only be received from your direct neighbour. So if your direct neighbour, your customer, tells you who his transits are, who his other transits are. Anything further away is maybe not trustworthy. I think perhaps the Tier 1 ISPs could trust their peers with this information, but too much further is not effective anyway, and you can't trust an AS 10 hops away. So you would put that statement there, delete large community in. That's the 41.001.001.00. That is the well-known number. And then you will put the word not peer AS. That means that if that next number is not your peer, it would delete that community. And the star means anything for the next one. The example here is if the AS path validity, which is that bit that the software sets, is leaked, then set your local preference. You could do other things, you could drop it, or you could just make it totally invalid, sort of like an X-top that's unreachable. And then on the outbound, neighbour outbound, you put, if you're not sending any, if you're not forwarding any RLPs that you received, then you just put that, so you delete them, and you put your own RLPs in like this, and you put additive. Whoops, I went backwards. Okay. This is pretty much the same. This is one with an AS that does have transit providers, and so the top part of that is the same. At the bottom part is say set large community. These are my two transit providers. I am 64500, and my providers are 64501 and 64502. So I add those two large communities. Like with the one before, this guy has no transit providers, so he sets large community with a 0 to say that he has none. Okay, so this one is just for a customer who's requesting route leak protection for his routes. So he just, on his neighbour out policy, he just says set these communities. So this is one for just setting communities. Set large community will be the same as the bottom one here. So set community is that one. But that only works for 16-bit ASes, and it cannot be passed on to your neighbours. And this was, this is automating the peer locking concept that Job Snyder's had provided some time ago, and I've got an IETF draft there. Oh, as a follow-on from Job's talk today, we are very interested in knowing what your thoughts are on the things that Job wants. I think in particular that one about the iOS causing the route leaks. If you want that, or if you don't want that, there's a lot of Cisco people doing brownie in motion around here, so if you bump into one, let us know. Questions?
Jeff Houston, APNIC. Look,
Jeff.
When you have a hammer, everything is not a nail. You have to exercise discretion. And this strikes me as a remarkably complicated approach to a really simple environment. As a BGP speaker in a routing system, all I want to do is not lose money. And preferably, I'd like to make money. I pay money to transits. customers pay me money. So this is really simple. It's called valley-free routing. What I learn from customers, I send to everyone because I get money from customers. What I learn from transits, I only send to customers because I pay money to those transits and I'm not going to give everyone a free ride. And what I learn from peers, I only send to customers. This only needs one bit. It's called the up bit. Right? You with me so far?
Yeah, I've seen that one, and we've seen it. We've seen the up bit.
When I learn it from a peer, I clear the up bit because it's gone sideways already. When I learn it from a transit, I clear the up bit. When I learn it from a customer, I set the up bit. When the up bit's set, I only send it upwards. That's all you need. So this seems an incredibly complicated approach to what is a really simple control problem. Don't send what you learn from transits or peers to other transits or peers. That's really what you're trying to say here.
Tell that to the leaking ASes. Right? Tell them to do that.
That's a remarkably complicated...
They don't do that.
That's a remarkably complicated approach to a very simple problem that you can do with a much smaller community than what you're doing here. So there are other proposals in the IETF. This is not the only one.
Yeah, I know.
And if this is a surrogate IETF BGP meeting, then I'm going to say the same thing here as I would say there. I just don't understand why it needs this level of complexity for a remarkably simple problem that we've been living with for the last 20 years. Thanks.
Center microphone, please be quick. We have only got 3 minutes for 3 comments.
Thank you for the talk, Jacob. I think you goofed slightly in saying you want to strip out everything except the peer ASes communities, because in your drawings you show that the RLPs have to be passed along so that the RLP for this AS goes through this AS and over to this one, so he can make the decision that that's not a valid pathway. If you're dropping the RLPs that are not from your peer AS, he'd never get the RLP from the guy down here. So just as a pointer, I think you don't want to strip the not peer AS RLPs. Otherwise, it only protects the people you're talking to and doesn't protect against that third hop route leak. The one other piece to this is, how do you make sure that the person who's leaking isn't accidentally rewriting the community and putting a community on that says, oh, this is a valid transit pathway?
Oh, okay. So I had some more to the rules there, which I did detail in the draft, and that is, if I get an RLP set directly from my neighbour, then that one trumps all of the others.
So you have a hierarchy of
yeah.
Okay, got it. Thank you.
Yeah. Joe Provo, Google. Matt hit my forgery rewrite question, but the other comment is merely for the 01 version of the draft, I'd suggest changing the order of the elements, how you write that, so it's consistent with 7454, and put my AS first, the way we did with the overall large communities.
No. In the large communities, you put the my AS first, right? But that is an indication of what the rest of them are.
Right. I was just meaning that 7454 recommends that you only pay attention to stuff with your AS, and then regarding security against people sending you signaling data that you don't want them to send, so the order of operations within that RFC recommends you only pay attention to stuff received with my AS first, and then don't strip anything else, because if we do it the other way, then we may have to update 74.
Okay, well, this one is to be a well-known large community that where the first number indicates that it is a well-known large community and we know what to do with it. Okay.
Yeah. So Rudiger, we're very much out of time. I think this is getting into hallway conversation, so the last question is at the back center mic.
I just want to point a little bit. I'm from Moscow IXP, and we already implement a lot of communities. And now most of platforms, most of vendors faced with the problems that it's became to grow amount of the community that it's assigned to one prefix. With this complicated approach, you just extend this problem too much. And now we also, and several IXPs, limiting amount of communities in the prefix. So it could be just stripped in case if it could be too much. So it's not, I think it's not a good solution for that.
Okay, yeah, he puts more communities into the route and it provides the service.
All right. Thank you, Jacob. Thank you, everyone.
Okay.